Hey, good afternoon. This is John Mills. As Steve mentioned, I'm the other air safety investigator here in Boise. We're going to talk a little bit this afternoon about, if I can pull it up here, King Cove. This accident occurred back in February of last year, just a little over a year from now. The accident involved was with a Super Cub from the King Cove area down at the Isabek Refuge. On February 11th, about 3:40 in the afternoon, the Isabek Super Cub took off from the Cove Airport. It was on a VFR flight plan. The airplane was being flown by the Fish and Wildlife Service National Wildlife Refuge pilot who was sitting in the front seat, and the acting refuge manager was the observer. And on this particular mission, he was also a photographer sitting in the back seat of the tandem-seat aircraft. The mission they were flying was to take a look at the route of a proposed road that was going to be put in and to take aerial photographs of the corridor. Now, the mission comprised of the standard DOI orange card items, plus it had some discussion on pilot carding, some of the survival equipment that they thought they might need, some of the PPE, and a review of the map of where they were going. Now, the personal protective equipment that they used on this flight consisted of the leather boots, the flight suits, inflatable survival vests, and helmets. There were no additional items for that. This shows the route of flight that they had taken. They took off from Cove. About 5 to 10 minutes after they took off, the aircraft flew over the Kendruff Lagoon to check on a couple of crews in refuge boats conducting a waterfowl survey. After that, they continued eastward toward the new, there was a new hovercraft pad out to the southeast of the lagoon. And when the pilot observed the survey crew working in the area, he decided to descend to about 163 feet to check on what they were doing out there. Once he was confident that they were okay and everything was progressing, he continued on in a southeastern direction along the road and continued down to another road known as a hovercraft road that extended northwest from King Cove, which is located just to the southeast of Leonard Harbor there, along the eastern edge of Cove Bay. Now, the maximum altitude that they flew in this area was about 750 feet over the water. Well, about 23 minutes into the flight, they were at approximately 745 feet. Going about 75 miles an hour, the engine started to sputter. The pilot stated that he thought the problem might be linked to carburetor ice, and he took several actions within the next 5 to 10 seconds. He stated that he checked the carb heat, he checked the fuel tanks, he checked the magnetos and the throttle and the mixture. After he completed those items, he thought that the engine seemed to regain a little bit of partial power for the next few seconds, but then it sputtered again and failed. The pilot stated that he deselected the carb heat to see if the engine would respond. When it did not respond, the pilot stated that he reselected the carb heat. Once the engine was completely inoperative, he initiated a mayday call to the flight service, who initiated their distress call immediately. This is a picture taken a few days afterwards. This is what the pilot and crew were able to see. This is the area that they had landed on. About 2 minutes and 15 seconds elapsed from the start of the emergency, or when the engine malfunction began, to when they landed on the road. The road was selected as the only landing site because really nothing else was available. There was soft tundra behind them with a lot of streams and open water. You can see on the left side of the aircraft, you've got steep hills with rocks and cliffs and trees. On the right side of the aircraft, there was a steep bank with the wet grassy tundra that went down to the ocean. The road was approximately 12 feet in width. some areas that were relatively straight, and elevation changes a little bit. It was primarily gravel with several small potholes. On the day of the accident, it had been raining a little bit, so the road was wet. The aircraft touched down on a 2-point attitude. Now, this is a tailwheel aircraft, so you know that the 2-point attitude, you just got the mains touching down and the tail wheel is not on the ground. And it had an airspeed of about 55 to 60 miles an hour. This is another view of the road that you can see as they were touching down. See if I can make an area. This is kind of the area what they were looking at for the initial touchdown. You see that red circle there. Well, the optimum landing speed for the aircraft would be about 40 to 45 miles an hour. So you can see it was about 10 to 20 miles an hour faster than it should have been. You know, that increased airspeed aggravates the ground handling characteristics and of course the stopping distance that's required. Once it touched down, the aircraft traveled for about 450 feet, where it then left the road, still in a 2-point attitude, and entered into a ditch, where it continued for about another 100 feet, where the right main struck an exposed culvert, causing it to pivot around about 120 degrees to the right. In this next picture, you can see this is the start of the touchdown. You can see the left main touchdown first, and then it touched a little bit to the right and continued a little bit around the corner. Now, these next pictures were actually taken by the observer that was in the back seat, and if you think about it, he's walking backwards or from the beginning back to where the aircraft is, and you can see the tracks that are on your left as you're looking at the screen are actually the right main tires as they go up. So we're going to follow that back. You can see a little bit more tracks. So you can see it kind of developing where the right main tire is predominantly the one that's on the road, with the left main being a little bit intermittent as it continues on. And a little bit further up the road, now you can see a pretty heavy impact from the right main tire, and again, intermittent marks from the left main. So now we're looking at forward to where the aircraft is leaving the right side, crossing over to the left side of the road, and then entering into the ditch. And here's that one of the last pictures. You can see the right main is predominantly all the way across into the ditch. The left main is still intermittent, and you can see that, if I can highlight it here, this marked dotted line right there, that's where the tail wheel finally makes impact with the ground as it goes into the ditch. There's another shot of that going up to the airplane. And these last pictures, you can see these marks actually show where the wingtips scrape the ground. Here's that culvert I'm talking about. Once it hit with the right main, it pivoted the aircraft around about 120 degrees, and it came to rest upright position. Now, neither the pilot nor the observer were injured at all, so they were able to get out of the airplane. The ELT did go off, so they were able to turn that off. Fortunately for them, a resident of King Cove happened to come upon the scene. You can see that the yellow truck there in the picture. Happened by just a few minutes after the landing, and then she was able to give them a ride back to the King Cove Airport, where they had arrangements for another pilot to fly over and pick them up. Here's some of the damage that you can see to the airplane. Primary nose cowling. You can see damage to the propeller. Obviously, there's damage to the gears. Let me do investigations, and we start putting our reports together, we look at what's called the 5M. We look at the media or the environmental conditions, the weather. We look at the machine or the aircraft, the mission that the crew were flying. We looked at the individuals that are in the aircraft. Then we take a big picture look at management and see how that impacts what they do. The weather at the time was actually a pretty nice day. They had an overcast layer at about 22,000 feet, great visibility, about 10 miles. The temperature is about 37 degrees with a dew point of 30 degrees, and a light wind out of the north-northeast about 10 miles an hour. What's interesting to note here is this is a chart of a carburetor icing probability. When you take a look at the environment that the aircraft was operating in based on temperature and dew point, you can see that the aircraft was operating in the serious icing range. So that's something that the pilot seemed to consider when he first suspected carburetor ice to be the problem. He went through the appropriate steps that he thought to take care of the carburetor ice. As I mentioned earlier, the pilot stated that he had thought that he had reselected the carburetor ice back on just prior to landing. Well, about 2 weeks after the accident, they were able to get the aircraft back in the hangar, and they had a couple of mechanics come down and take a look at that. They actually bought a new propeller, stuck that on the engine, and determined to see if the aircraft the engine would start up again. And what they found is that they were doing the inspection of the engine. This is a picture of the carburetor heat cable. And you can see that the cable is bent, and it's actually in the opposition. In the opposition, there was actually a little bit of slack or cushion in the cable. So as you push it too far forward into the opposition, you could actually bend that cable. And this was the condition that they found it when they did their inspection, showing that the carburetor heat was actually in the off position during the flight. They were able to put the propeller on and run the engine without any problems at all. Once they got the engine and aircraft back to Anchorage, they sent the carburetor up to FAA certified repair facility. They ran it through the bench checks, and they found a few minor problems with it, but all in all, the owner of the repair facility said that there's really nothing wrong with the carburetor that would cause a problem to make the engine quit. In his opinion, he suspected carburetor ice the same. Now we'll talk a little bit about the aircraft itself. It actually had just come out of a 100-hour annual inspection 3 days prior to the accident. The mishap pilot actually flew the aircraft on the post-maintenance check 2 days prior to the accident. Along those checks, there are numerous areas where they checked the condition, the carb heat, the brakes, the rudder alignment, everything is checked, and there were no discrepancies with the aircraft. What they had initially found is we'll go back and take a look at these pictures right here, and what you can see, the ground scars, when you take a look at them, show intermittent left and right tire tracks, as you can see, and the tracks are really consistent with the developing ground loop. So if the aircraft heading is slightly different from the aircraft direction of motion, a side force is exerted on the wheels. Now, if this force is in front of the center of gravity, the resulting moment tends to rotate the aircraft's heading even further from the direction of motion, and increases the force, and then the process reinforces itself. So you can see a two-point wheel landing that occurred in this particular instance actually increases the centrifugal force of swerving. So to be able to avoid the ground loop, what you need to do is make sure you respond immediately while you have sufficient control authority available to counteract the loop. Because once the aircraft starts rotating beyond the point, there's really nothing the pilot can do to stop it from rotating any further. So we have the developing ground loop. The pilot touched down almost 20 miles an hour faster, which attributed to the handling characteristics is aggravated, and resulting was the leaving the side of the road into the side of the ditch where the impact occurred.